go over the regression question for assignment number 4. And so there's all this output, and I actually go over this on one of my slides in the regression. I don't remember which slide, but it has a picture of all the output for regression, the same as for assignment number 4. Okay, so what is for assignment 4? One of the questions, the regression question, asks you to let me see exactly what it says. So it says write out the regression equation and explain the beta coefficients. Explain what the beta coefficients mean for each variable and which variables are significant. So all you need is actually the very bottom table. The rest of the table is above. So there is the model summary, then the ANOVA. Those talk about the model overall. It talks about the regression overall, whether or not it's significant. And I go more into this during my lecture. Okay, so for that particular slide, if you listen to the audio, it goes over that. And I do briefly talk about that last table, but I don't think I went over it with as much detail that's needed for the assignment. So I'm going to go over it now. So the very last table, I rewrote it out, but I didn't, there's numbers here that we don't need to go through, and there's numbers here. So this matches the table. Hopefully I copied it correctly, but we have that very last table, right? It has the model, then it has the constant. So what's happening with this regression model is that we're using a multiple predictors to see if how that predicts the outcome. And so the outcome measure, or the dependent variables, so we learned about dependent variables in, I believe, the very first lecture for the semester. But the dependent variable or the outcome measure is science score. And so we're using all of these other variables to try to predict the outcome. So we're looking at if you have different scores, how will that predict the outcome measure? Okay, so this is actually used for admission. So for example, should we admit a person or not? And they put in a bunch of variables and see how likely it is to actually admit that person. So let's just go over this, and I'll use like predictors for whether or not someone should be admitted to a school or how well they'll do in a college, right? So in this problem, the outcome measure is science score. Our independent variables is math score, female, social studies, and reading. So when you write out the equation, so the equation is typically y predicted. So this is where you would write your outcome measure, which equals, sorry, I need to make sure I'm doing everything correctly. So B0 is the intercept, or constant, plus B1 times, so whatever that weight of that variable, so B1 times x1, which is the variable, plus B2 times x2 plus B3 times x3. So, and so on to, I think it's Bn to xn. Okay? So however many variables you have that are predicting your outcome measure, that's how many constants you have for each of those variables. So let's go over this. So we have in our model, so that last table, it prints out what our constant is, or our intercept, so that's this. And then each of these beta coefficients correspond to these, so this is the same as this, right? And then this one will be the same as the second one. So this is 1, 2, this is 3, and so on. Okay? So how you would write your equation is just by using these numbers. So our y predicted, which is our dependent, this is from the question, our dependent outcome. So how I'm going to write this equation is science score equals our constant, right? Remember, this is our constant slash intercept is right here. So that's 12.325 plus, so it's, as I talked about in the lecture, regression is like a line. Regression is a line, right? That's what we're getting at. So this is our intercept plus our weight for mass score is point, I'm just taking this directly from the table, right? 0.389 times math score. I'm going to run out of room. Plus, okay, so it's a negative 2 point, so this would be negative 2.010 times, this is essentially a variable for gender, but they used female, plus 0.05 times social studies. So that's their score for social studies, right? Plus 0.335 times reading. That's the reading score. Okay, so that's the whole equation right here. All this. So essentially you have science score equals the constant, which I'm just getting from the table, plus the constant for math score, which is 0.389, or the beta score, right? And then minus 2.010 with times female, so that's the coefficient. And then 0.05 for social studies, and plus 0.335 for reading score. So this is the fourth coefficient. So once you have the equation, you can, how researchers use this equation, so once they generate that equation for regression, the way they use the equation is they get another individual's scores, right, or variables on that score to be able to predict what their science score would be. So if you imagine our outcome measure was actually like a measure, so let's say it's GPA in college. So then they try to predict GPA in college by using other variables to figure out whether or not to accept someone or reject someone, right? So they have data, they collect at their school, they collect data on just GPA of students, then they look at variables to see how can we predict this individual's GPA in college, like what are some predictors that we can use? So we can use their high school GPA for different, or their grade in particular classes, their SAT score, are these predictors of GPA in college? Yes or no, right? So that's one applied way I can think of that may be relevant to you all for using regression. But so let's continue on with assignment 4, right? So this is the equation, that's one part, and then we have to analyze what these beta coefficients mean. So the way that the beta coefficient works is that every one increase in the independent variable, right, because we're going from independent to dependent, every one increase in the independent variable or the predictive variable, there will be a 0.389 increase in science score. So how it works is when you have a 1 increase in the independent variable, this will correspond to an increase in the science score by the beta coefficient. Okay? So with increase in math score, and if you hold all other things constant, all the other variables constant, and you only change the math score, then you will have a plus 0.389 increase in science score. So that makes sense with our equation, right? So let's say everything is constant. So let's say everything's 0, right? And then all you have is your math score is 1. You increase it by 1. Then your science score will increase by 0.389, right? So if we're looking at the equation, that's another way to remember it. So for female, if you increase it by 1, gender, so gender was coded 1, 0. So if you have a 1 for gender, then you'll have a minus 2.010 for the predictor. It would decrease by, the science score will decrease by 2.010. Okay, this is hypothetical data. Then if you increase social studies, holding all other variables constant, increase social studies by plus 1, then science score will increase by 0.05. Okay? And then again, our predictor variable, right? Or sorry, our dependent variable. Then if you increase reading by 1 point, then you'll increase the science score by 0.335. Okay, so that's how the beta coefficients work. The next part of the question for assignment 4 was looking at whether or not these beta coefficients are significant. And the way that you would look at that is by using the t-statistic in that same table. Okay, so the t-statistic for the corresponding row corresponds to whatever is on this side, right? So the constant for any regression model is always significant. That's just how it is. So I usually just ignore this. I'm just interested in my beta coefficients, right? I'm interested in, is math score really a good predictor of science score? And what we find is that the t-statistic is 5.252, and that is very significant, right? The p-value is 0.000. So that essentially means is less. So we're looking for a significance level that's less than, what you're looking for is something that's less than 0.05. So that's lower than 0.05 to say that is significant. So that's what we use, okay? So math score has a significance variable of essentially 0. So this is highly significant. So that means math score is a predictor of our dependent variable science score. Okay, so those are actually two variables that are related. We go to the next variable. This doesn't quite meet the cutoff. Sometimes so I wouldn't even count gender as a variable within that is a predictor. Okay, so because it's above, do you see how it's 0.051? It's above 0.05, so I wouldn't consider it a predictor. Then we go down to social studies. The t-value is 0.801. The p-value is 0.424, so that is not significant. So I want to consider that a predictor of science score, or dependent variable. Then finally we have reading. The t-value is 4.607, and that's highly significant. This is also significant. So I would consider, so that means reading is a predictor of science score, is significant. Okay, so that's how you use that table. So for the homework or for the assignment, you have to write out this equation, and then I want you to say, math score has a beta value of 0.389. So that means every 1 increase in math score, there will be a 0.389 increase in science score. And because the t-value is significant for math score, that means it is a significant predictor for our dependent variable science score. And so that's how you would just look at, that was just for one variable. You would have to go through every single variable. So there's 4 variables to go through. So I would expect something similar to that for math score, female, social studies, and rating.